So, in the last class, we were discussing about 1 minute. Where is that presentation? Google Drive. Hadoop. IT Varsity. The HDFS. So far we have covered these 4 questions, and now we will discuss what is a gateway node. Okay. So if you look into the cluster, if you log into the cluster, and the cluster is primarily divided into masters and slaves. Masters are the ones which will run the daemon process, such as name node, secondary name node, resource manager, Hive server, etc. So there will be a background process running for the service which serves as a master. And data nodes are the slaves. Data nodes, node managers, etc. will be running on slaves, which will store the actual data and which will actually perform the processing. And on top of these two, masters and slaves, it is always better in production clusters to have an additional node called gateway node or client node. If you are using AWS, they use a term called bastion server. So all these three means same: bastion server, client node, or gateway node. So what is the role of the gateway node? If you go to the whiteboard, okay, so you have, it is called as bastion server. So let me ping you guys. Okay. So here you have the cluster. There will be masters in it. I will get a license for better whiteboarding software. Right now I don't have licensing. That will be much better than this. It will be ready by Monday. Okay, so there will be masters and there will be slaves in the cluster. Okay, slaves will be running data nodes, which are which is the HDFS component, which will manage storing actual data in the form of blocks. What is block and all we will understand as part of the next question. And also for processing, they will have something called node manager if you are using YARN for the processing. On masters, you will have name node, secondary name node, resource manager, and for Hive you will have additional masters. So on. For many other tools, you will have masters. You might not have components on slave nodes, but you will have components on the masters. So there will be more and more physical servers. As I have explained earlier, even in a 1000 node cluster, there will be handful of masters, probably up to 8 to 9 for different purposes, which you will understand slowly. But most of the nodes will be slaves. Okay, and when you actually face the interview question, when they ask about cluster sizes, even though you say that you have worked on 6 node or 7 node clusters for POCs, you should be able to confidently say that you can support even the 1000 node clusters. Typically the nodes will be 30 nodes to 1000 nodes, depending upon the size of the project which we are trying to deliver on big data. And it is not just enough to tell appropriate number of nodes in the cluster, but you should be able to explain what is the memory on each of the node in the cluster, what is the number of CPUs or cores on each of the node in the cluster, what is the storage that is mounted in the cluster. So when I actually I have interviewed tens of people in Hadoop. So when I typically ask them what is the RAM on your node on each of the nodes in the cluster, let's say 2 GB, 4 GB, because they will be using their laptop to practice using the plain vanilla single node setup, which is absolutely incorrect. Um, it I will tell you how to answer that question more appropriately. For that, you need to understand the capacity on each on the nodes which we are practicing for lab, and then you have to do homework. How other clusters. So, for example, if you search for benchmarking in Hadoop, there will be a lot of articles, and they will explain you what is the RAM on each of the nodes. First, they will tell how many nodes they have used for benchmarking, what is the RAM on each of the nodes, how much storage is there, how many CPUs or cores are there on each of the nodes in the cluster. So you have to understand those articles so that you can answer that question in more appropriate fashion, not only for the interviews but also for while performing assessments or while proposing the solutions to the clients. You have to do capacity planning more thoroughly. Okay. Anyway, we will re-emphasize on those aspects several times by the end of the course, so that you understand it, and also it become intuitive to you, rather than thinking about the answer at the time when you face the question, and then provide inappropriate answer. I will try to make it intuitive so that you don't need to worry much about answering that question, because that question is one of the very, very important question which can tell whether you have appropriate knowledge about Hadoop or not. We don't need to ask any other question. That question is good enough whether you have appropriate knowledge in Hadoop or not. Okay. So coming back to our main question, gateway node. So we have master slaves. So each of these nodes are capable of running Hadoop fs-put command, the way we have done as part of the last class in my lab, to store a file. Okay, you can run on each of these nodes, and also we can actually run the MapReduce jobs also, or Hive queries also, mostly on each of these nodes. So what will happen is, if you start submitting the jobs, or if you start loading the data from the Hadoop cluster itself, there will be the contention. For example, if you start submitting the jobs from one of the nodes, or from several of the nodes in the cluster on daily basis, there will be contention between your job submissions and job execution. For example, let's say you pick this node and start submitting almost 8 jobs in parallel on average, all the time. And let's say the capacity of this cluster is 16. Sorry, capacity of this node is 16. So this is capacity. And this is the average number of jobs you are submitting from this node. So when you actually submit a job, what will happen is, it will take away some capacity from the node. So for example, that 16 is, let's say 16 cores. When you actually submit the job submission also involves like creating a JVM and copying the resources, make sure the job is running, etc. So there will be a lot of overhead when you submit the job. So on average, if you are submitting 8 jobs all the time from this node, when your capacity is 16, half of the capacity will be taken away by the job submission itself. Okay, only half of the capacity will be available for the task to execute on that node. So in that scenario, what will happen is, there will be contention between job submission and job execution on some of the nodes in the cluster, and it can slow down the overall processing. Similarly, when you try to load the data, if you try to copy terabytes of data on regular basis, copying terabytes of data into HDFS will take some time. And as long as the copy takes place, there will be resources allocated for the copy process, like creating a JVM, etc. So that one also can contend with other tasks that needs to be performed for the. So again, as I mentioned to you, on average, I am submitting 8 jobs in parallel. Okay, it requires some CPU, it requires some memory, and all those things. Means this 8 is not complete. Means half of the capacity is not accurately correct, but it can take up to half of the capacity depending upon the complexity of your job submission. When you submit the job, in some cases, it will actually do lot of uh, 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 so when you submit the job, you are executing a Java program, and the Java program can do anything. Not only start processing the data, but as a pre-processing activity, we might have to develop some logic to make sure data is available in the cluster, or any pre-processing activity you have to take care. You have to embed in the logic of that Java program, and in that scenario, it might even be taking more than half of the capacity. I gave half of the capacity as a hypothetical number, but the main point you need to take is there will be contention between the job submissions and the job execution. That's the main point you need to take. Okay, and also when you try to copy the data, if you let's say you start using name node itself to copy the data into HDFS. So copying the data is not just running Hadoop FS -put command the way I have done earlier. You have to deploy a complete data integration platform which can get pull data from several sources and load into HDFS. And also, if for some reason, let's say there is a bug in the process, you get the data and you started getting incorrect data with the latest upgrade, okay, and then they realize that there is a problem. So you might have to reprocess the data again after fixing the bug. You have to reload the data and you have to reprocess the data. So to troubleshoot whether there is a bug in the data or not because of the bug in the code, you need to have the data staged somewhere, okay, so that we can troubleshoot the issue, and if it is required, we can reprocess last 2 days or 3 days worth of data, etc. So for example, let's say you are getting 100 GB worth of data every day, okay, and you are trying to process this 100 GB data into the Hadoop cluster, and we cannot just flush this 100 GB files after loading into it. We have to define SLAs for how long this data has to be retained, so that in case there is a bug in the code, if we have to reprocess the data, how long we can support in such a way that we don't need to go to the source system and get the data. Okay, so for that reason, what we have to do is we have to define something called gateway. So the gateway will have the necessary capacity to stage the incoming data from several sources, and it is like a staging area before loading into the HDFS, and then we will deploy the applications on the gateway itself to load the data into HDFS and also to process the data after loading the data. So it has to be self-contained application which will actually load the data into HDFS and then process the data immediately. And also another advantage of having gateway node is if you are submitting hundreds of jobs concurrently, you can scale up by having more gateway nodes. You can load balance in such a way that some of the jobs related to one application or a set of applications go through one gateway node and the other go through another gateway node. So like that you can have up to 2 or 3 gateway nodes. I have seen environments up to 3 gateway nodes, but it can be more also depending upon the number of jobs and amount of data, number of applications you have to support. On a 1000 node cluster, probably you might have to have 3 or 4 gateway nodes, and the storage has to be network mounted. Yes, gateway node. So there is a question whether gateway and edge nodes are same? Answer is yes. Gateway node, edge node, client node, and also Bastion server in the AWS world. All are same. And then there is one more question which I could not capture. So when you actually ask the questions, make sure you ask by selecting everyone. Don't send it to me privately so that I don't need to reread the question. So can you give an example of a job? I am missing context of the job here. So we will get it once we talk about MapReduce. You will understand what it is. I am just giving examples here. Even we will revisit gateway on each of the topics. For example, we will be learning Scoop, Hive, Spark, etc. So at each and every topic, this gateway concept is relevant, and we will talk about that. Okay. Don't worry if you don't understand what is job here. You will understand slowly. For now, just remember that gateway nodes are nodes which are part of the cluster, but they will not run any daemon process such as name node, secondary name node, resource manager, etc. And now I am actually logging into my lab, which I am using to demonstrate. This is not the same lab which you will be using in CloudX. Okay, I have to restart because I always stop and start before the class, so I have to restart so that some of the errors go away. Anyway, now if I click on HDFS, if you see, it shows there are two name nodes. Don't worry about this, what is this journal node, etc. The main things which you need to emphasize on are name node, data node, and gateway. Okay, and if you see there is one gateway, we can click on this, and this IP address has the gateway, which is 172.31.53.242, which is one of the hosts in the cluster. And if I log into that using terminal, okay, and now if I run ps-ef grep node, so name node and data node both have node in common, so I am using node here. Always better to use -i so that it actually search for case insensitive. So even if there are if the word is mixed cap in the process name, grep-i will make it case insensitive, and it will try to compare with words with mixed cap, with case insensitive rather than case sensitive. So now you can see that there is a journal node process running here. There is a NFS3. So this is the place where you have to look into. After Java, you will see -D, and this is the actual process name which you will need to look into. It has something called journal node, which is not directly related to name node and data node. As I have a smaller cluster, I have deployed one of the component on gateway, but typically in production you will not have any such things in gateway. And then this is NFS3, which is completely different, and there is node somewhere in this, that's why it is showing up, but actual process name does not have node in this. So if you want to be particularly sure about about it, then it's better to search for the actual data node and name node itself. We don't have data node on this, and also we don't have name node on this. Okay, and if you log into any of the other hosts, in the cluster. Now I am in 245, and if you go back to the instances, 245 have the data node. We can actually sort it by host, so that if there are multiple components on 245, we will immediately know. So there is only one thing called data node in 245. And now if I run ps -es grep node or grep -i node, and you can see something called node manager. You can ignore it for now. Node manager is a processing slave. You will understand that later. You have NFS3, and then at the end you have proc_data node. So this is the one which is actually responsible to manage the blocks on this host. What are those blocks and all, we'll talk later. The main thing which you need to understand from this question is, there will be some nodes in the cluster which does not run any daemon process, but will be used to stage the data coming from the sources, and also to submit the jobs or applications in the cluster, and those are called as gateway nodes. So what is that gateway? Gateway have to just understand where the Hadoop cluster is, so that it can understand the jobs. It will be part of the cluster. You will not set up gateway on a remote host completely outside the cluster and expect it perform well. It has to be part of the cluster within the same rack, but only deviation is it does not have any daemon process. It will have the configuration files or parameter files such as post-site.xml, HDFS-site.xml, etc., so that it understands what is the name node, what is the resource manager, to load, to use the cluster for storing the data, and also to process the data. Okay, I hope everything is clear about gateway for now. We will again revisit several times so that you understand it thoroughly. So now we will go to the next question. What is block size, and how data is distributed? So again, the way they use the concept of file abstraction. Again, file abstraction means a given file can be larger than any one given hard disk. It can reach up to the capacity of the cluster. If you have 5 terabytes of capacity in the cluster, your file size can be 5 terabytes. Even though any one of the hard disks is no way close to that 5 terabytes, still your file can be 5 terabytes. That is the concept behind file abstraction. How file abstraction is achieved in HDFS? By using a concept called block. And what is a block? So in HDFS, file is just logical. So let me revisit here. So earlier I have ran a command. This one, Hadoop fs -capital D dfs.replication equal to 1 -put decafcards.txt user root cards. So this is the local path, and this is the HDFS path. I have ran this command. Okay, and in local file system, I can find this decafcards.txt wherever the file is. Okay, in HDFS, you have to use Hadoop fs -ls user root cards, and you can see the decafcards.txt in this. So this is just a logical file. Why I am saying logical is, if you go to any node in the cluster, and if you try to search for this file decafcards.txt with size 4.5 GB, you will not find anywhere, because it will not be stored directly like that. Instead, to implement the file abstraction, what it will do is, when we run the Hadoop fs -put command, there will be a JVM created, because the underlying code, the underlying implementation of this Hadoop fs command is nothing but Java code. Java is used to implement. So when this is executed, it will try to execute a class in the jar file in a JVM. So it will create a JVM on the fly, and then it will pick this takeoffcards.txt, which is there on the local file system. It will split it into blocks, and those blocks will be stored in HDFS physically. So the file in HDFS is logical, but the blocks are physical. So block is the physical component using which it will store in HDFS. So how it will store? Using a component called block size, and by default block size is 128 MB. We can get it by going into etc Hadoop conf. So this is the standard location which will have the configuration files. /etc is for any software. For each of the component in Hadoop, there will be a directory. For HDFS and MapReduce, there is one common directory called Hadoop. But for all the tools, you will have a separate directory which will have this conf directory. And under conf, you will have this hdfs.xml file which will have the parameters which will define the block size, replication factor, etc. So view hdfs site.xml and then block size. Okay, and this is 128 MB. This is in bytes. If you translate it into MB, it is 128 MB. So using this block size, it will try to split the file into multiple blocks and store into HDFS. And to get the details from the command prompt, you can run this command called HDFS fsck. You have to give the path in HDFS user root cards takeoff cards.txt and then files. So you can give path, sorry, hyphen files, not slash files, hyphen files. These are control arguments. HDFS fsck path, and then you can give control arguments for different level of information. If you just give the directory rather than files, it will give hyphen files will give all the files that are there in that HDFS directory. Okay. First I will run files, HDFS fsck, the path of the directory, and then hyphen files. So the path which is given is nothing but the directory, and then it has only one file of size 45 GB. Okay. And if you want to get other information, so here you can see that there is a block size of 128 MB and all. Also it provides details such as default replication factor, etc. But it does not provide any other information that is required to understand how the file is stored. For that, you have to use another control argument called blocks. So it will tell what are the block names which will be physically stored on the cluster. So hyphen files will just give the file name which is just logical. Hyphen blocks will give the files which are created to support the file abstraction by dividing the file into blocks. So block is the physical entity, file is a logical entity in HDFS, in the context of HDFS. Okay, now you can see we have 4.5 GB of file, and that file is divided into 34 blocks. Here you can see this is the block index, just the block number given for each of the block. So we have 0 to 33, so there are 34 blocks, and this is the name of the block. Okay, so the first 128 megabytes of that 4.5 or 4.3 GB of data will be stored in this block, and the second 128 megabytes will be stored in this block, and so on. And if you see the last one is only 110 MB, not 128 MB. Whatever is the leftover, the block will be allocating storage only up to that amount. Okay. And another thing which you need to understand is, if you see, this block ID is in incremental order of the block index. So first one starts with 4063 and ends with 4097. On a very active cluster, the block IDs might not be serial, they can be separated, but it will be in the increasing order only. It is also unique. So these block IDs are unique across all the files in the cluster. Once a block ID is allocated to a block of a given file, that same block ID will not be given to any other file because these are the physical files which have to be stored in HDFS, and if you try to use the same block ID across multiple files, then there will be issues. So this block ID is unique across all the files in the cluster. Now let us see how it is stored in the stored physically. To get that information, you can add one more control argument, locations. So hyphen files to get all the file names in the given path, hyphen blocks to get the physical names of each of the block, and then locations to actually get the locations of the file. And these locations can change over time because of the load balancing happening on the cluster. The blocks will move between the nodes, hence the locations can change. And block IDs will remain same, but the locations can change over time. There is a question. Let me take that question. The question is, what about replication in other nodes? We will talk about replication later. Here, just try to understand what is block size and how it is stored. Then we will talk about replication. Okay. So now we have all the details about our files in the path, the block IDs for each of the file, and also the block location. If you see the output of the difference in the output in the last run of this command and current run of this command is this one, data node info with storage, and this is nothing but a physical IP address of a particular data node. So this block index with 10, this block with index 10 is stored on 247, and this block with index 9, is stored in 245. So let's go to the 245. Let's copy this. Yeah, it's in 245. So those block, so there should be files with those block names or block IDs in HDFS. So where it will store? So when it comes to HDFS, again the locations where these blocks needs to be stored is controlled by parameters. So you have to go to the configuration. And also keep in mind that you might not be able to do all these things in the CloudX lab. And as a developer on day-to-day job, you don't need to have access to these locations. Okay, but you should have knowledge so that you can face the questions with more confidence, and also you can troubleshoot the issues. Okay, so that's why I'm highlighting these things quite extensively. But as a developer, you don't need, you might not have access in the production cluster. You have to work with administrators to get these insights. Okay. So now there is a directory called there is a parameter called data node dot. Let me see. Let me search for DAR itself. Okay, so there is a parameter called DFS data node data DAR, and this is the path. So in production cluster, for each hard disk there will be a mount point, and those mount points will be having the same names on all the nodes in the cluster. So if there are 4 hard disks on each of the node in the cluster, there will be 4 directories here. Okay, so under /DFS, which might be base directory, you might have DN01, DN02, DN03, DN04, etc. In production clusters. Here I have only one hard drive mounted on each of the node in the cluster. Hence, I have only one entry, but in production you might have multiple entries. So this DFS dot data node dot data dot DAR, whatever value it has, that is those are the locations on all the nodes in the cluster which will have the blocks. So here, now we will go to that location DFS. I am going to the base directory only. I am not getting into the subdirectory. And now we can actually run a command called find dot. This is a Linux command. It is nothing to do with HDFS. I am just trying to search if there is a file with the name using this block ID on this host, because when we run HDFS FSCK command, uh, the the block this block the file associated with this block with the index 9 is on is on 245. So we connected to 245 and we are trying to search if it has. So let me use star here. Let me use patterns rather than the complete file name. You can see here. Okay, so there is only metadata. There should be file also. Let me see. Find /name. So it should have the, okay, I know why it is not coming up. So this is the block ID. Underscore 4072 is for some other purpose. So you can ignore that. So block ID is only up to this one, not underscore 4072. And if you search now, you can see that there is a file in the local file system on 245 which matches with the block ID. And also you can actually see the properties of that file. So xargs is again a Linux command which can send the output of this command as the parameter to the piper command. So we are piping the output of this find command to ls-ltr using xargs so that we can get the actual file attributes, whatever is the output of the find command. Okay, so here you can see that this file which have blk underscore 1073, whatever the block, whatever the file which have the block, just block ID, you can see the properties of it. It is 128 MB file, and then there is .meta file for each of these files, which will have the metadata of that, which you don't need to worry about, as long as you understand that the file is divided into blocks based on the block size and stored on data node physically. That is more than enough for this question. So I hope you are clear on what is block size and how data is distributed. So once the file is divided into multiple blocks, HDFS will try to store these blocks on as many nodes possible in the cluster. So if you have 1000 node cluster, these 34 blocks will go to 34 different nodes. If you have 10 node cluster, each one will get 3 blocks depending upon the load on each of the node at that time. On average, each one will get 3 blocks. So that is how the data will be distributed. Okay, any question on this? This is again very, very important before we go to the next, another very, very important. Okay, it's a very good question. The question is from Mohan, and if a block is corrupted for some reason, then will name node take care? So the way the corruption is handled, right? When client try to copy the files in the form of blocks, okay, it can be corrupted because the original file is one single file of 4.3 GB, but now it is being distributed into 128 MB blocks, and they are being physically stored on multiple nodes in the cluster, and these have to be transferred between the gateway node and the data nodes over the network, right? So the blocks might get corrupt anywhere. It can corrupt while the files are being splitted into blocks, while the blocks are being transferred over the network into the data nodes, and also while those blocks are being saved on the data nodes. It can get corrupt anywhere. For that reason, what HDFS will do is it will generate checksums. So on the client side, when the block is being generated by splitting the file, it will create checksum for each block, and then it will send the block to the data node. Once the data node saves, while it is being saved, data node also will generate a checksum. Okay, and that checksum will be passed back to the client as a response for copying this for copying the so client will make a request to the data node to create a copy of that block on the data node. Once the data node copies that block, data node will send back the checksum which is generated on the data node as a response. So now client have the checksum which is generated by itself, and also the checksum which it has retrieved from the data node, and it will compare these two checksums and will make sure whether there is any corruption or not. As long as checksums match, it will consider that there is no corruption, and it will treat the copy as successful if there are no corruptions of any blocks. Otherwise it will fail. Okay, that is how the corruption handled. What is the checksum? So most of the guys are new here. So what is the checksum? Checksum is nothing but a hash value of the file. What is hash value? If you are not sure, you have to Google it and you have to understand. So just Google about checksum and hash, you will understand. It's a industry standard way of doing things. They are industry standard words, checksum and hash values. Just understand those things, and also this is also industry standard way of comparing the file transfers. If file is transferred successfully or not is always done by generating checksums. So here it also uses the same concept. Okay, I hope it answers your question, Mohan. If not, you can have a follow-up question. Murali is asking a question. Again, please ask the questions so that it goes to everyone and they have the record of it. Murali have asked me a question. Client here is edge node or my local computer. Client here is edge node. You will not run Hadoop FS commands from your client, from your local computer. You always run from the edge node or gateway node or client node. Okay. Most of the times your local computer cannot be client also because the gate cannot submit the Hadoop FS minus put commands also. The reason is your local computer might be Windows laptop and your cluster might be on Linux, so you cannot actually interact with the with your Hadoop cluster which is running on Linux from your Windows laptop. You have to connect to the gateway node to perform anything on the cluster. Okay, so whenever I say client, I hardly, which means it's a gateway or edge node. We will not do anything from the from our local machine, except in MapReduce, where to test against the development cluster. You can actually before submitting onto the Hadoop, you might be able to test it over in your PC, and then you compile the jar file and ship it to the cluster and you will run from there. You will understand when we talk about MapReduce. Okay, so next question is, what is fault tolerance and what is the role of replication factor? Okay, now you will understand what is replication factor, etc. Once we go to this question. After this question, we will wrap up. We will also take what is default block size and what is replication factor, and then we will go on to the next topic. So the reason why I am spending a lot of time on this is, even though these are not very relevant for the certification or day-to-day work, this is very important. These questions are very important to face, to answer the questions you face at different levels. It could be interviews, it could be assessments for the clients. Etc. So it could be assessments for the clients, etc. Okay. So now let us go to the default block size and what is replication factor. Sorry, what is fault tolerance and what is replication factor, what is the role of replication factor. So you see that I have ran this command. So again, I'm going back to the gateway node, which is 242 here. So 242 is gateway, 245 is one of the data nodes in the cluster. I'm going to my home directory, and here, if you recollect the command I have used to copy, okay, I think I have to use this one. Yeah. So to copy the file is this one, hyphen capital D, dfs.replication equal to 1, hyphen put deckofcards.txt, blah blah blah. And again, we will review how the file is stored. Last time we ran HDFS FSCK command. Now we will use something called name node web interface. Okay. So for that, actually I have to enable something called SSH tunneling on my lab. You don't need to be worried about these things. If you have to worry about, I will explain why I am doing this. For now, just ignore what I am doing. I am trying to access my cluster using private IPs by using concept called SSH tunneling and Foxy proxy. Okay. Now, what we are trying to do, we are trying to get access to name node web interface. So for that, first we need to understand where our name node is running. So if you go to the instances, so there is a active name node and there is a standby name node. I have active passive configuration here. You will understand what is this later. For now, I will try to connect the name node web interface of the active name node. So which is this one. Okay, so 244.ec2.internal. There will be a web service which will be running on the name node on port number 50070, and this is accessible whether it is Ambari or Hortonworks or even the plain vanilla Hadoop. This is the part of the open source Hadoop itself, the web service to support the user interface or web interface for the name node. Okay, 50070 is the default port number. Again, it is controlled by the parameter. If your administrator change the parameter to point to a different port number, then you might not be able to access this one, but hardly anyone changes this. So once you know the name node IP address, even though you don't have access to our user account on the name node or in the cluster, you can use this IP address with the port number 50070, and you will be able to see your directory structures and file structure using this web interface. Okay, so here you can go to utilities and browse the file system. I will cover the there will be a video in YouTube channel where I will cover the overview about the name node web interface. You can watch that. You can watch that to understand more about the name node web interface. For now, just we will use it and try to access the Hadoop, HDFS. So user root cards. So this is the location where I have created this deck of cards.txt file. Okay, and here you can see replication factor as 1 and block size is 128 MB, and you can hello guys, can you hear me? Someone is calling me and it is taking me to hold all the time. So let's just confirm that you guys can hear me. Okay. Okay, so you can see here block 0 to block 33. These are the block indexes which we have seen earlier, and this is the block ID. So blk underscore this one will be the name of the physical files, and this is the IP address on which we have the files or blocks associated with the file. Okay, now what will happen if I if 245 goes down, block 0 is on 245. If 245 goes down, as this block is only on one host, you will not be able to read the data. Okay, so fault tolerance means even if there are some failures, for HDFS, the extreme case, one of the extreme cases where the failures happen is the node itself can go down. So even if the node goes down, there should not be any impact to the applications. So that is called as fault tolerance. Your cluster has to be fault tolerant. Fault means any issue that happens on the cluster. One of the cases is the data node, one of the data nodes going down. Okay, so even if 245 goes down, if we have to support it, in this case it is not possible because we will not be able to recover this file because we have only one copy of this block on this one host. Hence, we will not be able to get our deck of cards back to read or process. For that reason, we have to. They have introduced a concept called replication factor. By default, it is 3. So there will be at least three blocks created. 3 copies created for each block. So now, what I will do is, I will try to delete this file. So Hadoop fs -rm with the command to delete root cards deck of cards.txt and hit enter. Okay, now it is deleted completely. Now I will try to load again, in this case with replication factor 2. Instead of 3, I am using 2. Default is 3. If you want to use default, you just delete it. And the administrators might decide a different replication factor also. In that case, dss.replication is the parameter in HDFS.xml file, which will actually set the default replication factor for you. But if they don't use that parameter also, the standard default value is 3. So there will be 3 copies of each of the blocks. So it will take a while to copy, and then we will review. Meanwhile, we can take up the next question. What is default block size and what is replication factor? By now, you should be able to memorize it. Default block size is 128 MB and replication factor is 3. In earlier versions of Hadoop, default block size is 64 MB, but now it is 128 MB. So what is hyphen? So there is a question. What is -d in HDFS command? So the -d is a way where you can override the parameters. I think I have covered as part of the last class. Either you can use -d dfs.replication -d and then the parameter name and value for that parameter, or you can also put multiple parameters in one file and use -conf if you want to override the parameters while copying the data. So -D is a way to override individual parameters while performing a task. It is applicable not only with Hadoop FS command, you can also do that while submitting the jobs later. Okay, and the next question is, what is actual replication factor in industry? So most of the guys are happy with 3. Sometimes, depending upon the relevance of the data set, very important data sets, they might have 4 or 5 as replication factor, and as you can change it at each file level, you can actually segregate what is important data and what is less important data, and you can play with it. You can, at least you should have 2, even for less important data. For more important data, it's up to you to decide. It can go up to 4 or 5, not more than 5. Okay. Another question is, if we don't have access to conf folder, how can we know replication factor? Very, very good question. Let me see. I think the name node web interface might have the details. So if you go to the summary, Okay. If you have access to HDFS FSCK, you will be able to um, run the HDFS FSCK command, and you will get the details. So as we run HDFS FSCK last time, at the end there is a report summary, and here you can see the default replication factor. This is one way, but there should be another straightforward way, because the HDFS FSCK you might not have access to. Okay, let me see if there is any command in Hadoop FS to get that. No. So I will get back to you on that. Probably there might be another straightforward way, but one way is HDFS FSCK. Okay. It's a very good question though. So anyway, you can override it if the parameters are not final. You can override either of these parameters, and you can customize a little bit. Okay, and we will take this question also. Given a scenario, we will take these two questions also to wrap up HDFS, and also let me see. And also we need to understand what is typical configuration and what is active-passive configuration. We will cover that as part of the next class to wrap up HDFS. But before going to the next class, we will actually take these two topics also. So given a scenario, how files are stored in HDFS, understand size of each of the block and replication factor. It is very important, especially for certification. There could be questions in Cloudera CCDH exam, which I have faced earlier. There are questions something like this. They will give a scenario and tell how a file will be stored and what is the size of the last block, etc. So for that, it's very simple. Go to this, browse the file system, user, root, and also before going that, let's see. Now the HDFS fs-put command is done. Now let us see how each of the block will be. Now you have two copies of each of the block. Block 0 is on 245 and 247. Similarly, block 1 is on 246 and 247. So even if one of the nodes goes down in my 4 data node cluster, still I can retrieve the data. But if more than one node goes down, in this case if 2 nodes goes down, then let's say 246 and 247 are down, then I will not be again I will not be able to retrieve the files again. So it is only sustainable with one node. If the replication factor is 3, not more than 2 data nodes can go down in cluster setup like mine. But in production, they use a concept called rack awareness. So you need to understand that rack awareness also to understand how the failures are mitigated even at larger scale. I will explain rack awareness. Okay, I will ping it. Yes, before going further, Gopi is asking the question whether we can see in 50070. Typically, yes. Even in CloudX Lab, you should be able to do it. Let me show you how you have to figure it out in CloudX Lab. It is a little bit tricky. Okay, so I am logging into CloudX Lab. I will explain rack awareness in a moment. First, let me answer Gopi's question. My lab, and you can go to IP mappings here. Okay, so the name node is running on this, so you have to use this one, 50070. is the port number, and you will be able to access the name node web interface. To get the IP address before going for the mapping, you have to go to this tab, lab credentials, launch Ambari. Okay, log in with the lab credentials. And password. Okay, actually they didn't open up the 50070 port in the lab. That's why it is not coming up. I will remind them to open up the port number so that you can have the name node web interface also. Okay, as of now they have not opened up the port in the firewalls. That's why you are not able to access. Typically in production clusters, if you are a developer for an application, you will get access to 50070 port where you can actually look at the HDFS web interface. How Morally is asking the question, how backups work in a cluster? Will there be a backup cluster to one cluster? What is that? Okay. So I will explain backups later. Actually, backups is more relevant for administrators than developers. Yeah, I will explain that portion later. First, let us see what is rack awareness. Okay. So rack awareness, let me go to the whiteboard here and let me create a new file. Let me delete this, let me close this one because these things will take a lot of memory. So better to close immediately. Okay, create new. Okay. So as I have explained earlier, let's say you have one rack. Rack is nothing but a container which can have multiple servers. If you look into the any data center images, you will find big racks. Racks will look like our almirahs or shelves. Okay, and in that they will set up all the network switches, the servers, which will look like our desktops, the storage servers, whatever is required to run the applications, everything will be there in that rack, and all these things will be connected through fiber net optics or whatever is decided for the setup of cluster. Okay, so let's say you have all your data nodes in one rack. And then all these things are connected with network switch. All the nodes, including name node and data nodes, are in one rack, and all of these things are connected through network switch. Okay. Now with replication factor 3, in this setup, it can survive the faults up to 2 nodes. The fault can be anything. It could be hard disk failures on one node. It could be a motherboard crash or motherboard failure on another node. Okay, so up to 2 nodes, the cluster will be up and running without any issues with replication factor 3, as long as there are no failures at the network level. But if the third one fails, immediately your cluster will become unstable and it can have adverse impacts on the applications. For that reason, what they have decided is, on large production clusters, we can have multi-rack environment, where instead of having all the data nodes in one rack, you can have 2 or 3 racks. Okay, and instead of having all the nodes, you will divide all the nodes on multiple racks. And now the HDFS is smart enough that if you try to store a file with replication factor higher than 1, okay, so the blocks of that file will be copied to at least 2 racks in the cluster. Okay, Even if you have 3 or 4 racks also, it will try to store at least onto 2 racks. That is called as rack awareness. So if your cluster is set up using servers on multiple racks, so this is rack 1 and this is rack 2. Okay, and now even if the complete rack goes down, still your data is available on the second rack. So your data, it will try to store at least on 2 racks. That is taken care by HDFS itself. HDFS have a script called rack awareness script, which you need to plug into the which administrators have to plug in, and that rack awareness script will make sure that the blocks, the files with more than replication factor 1, the blocks associated with them are stored on multiple racks, so that even if your network switch goes down, one of the network switch goes down or the entire rack goes down, still your cluster will be up and running supporting the applications. In this setup, there will be additional network switches which will connect these network switches so that it does not rely on only one network switch. Rather than connecting all the data nodes onto one network switch, which is part of one rack, there will be a dedicated network switch within the rack, and there will be external network switch. These two network switches will be connected with the external network switch. Hence, even if one of the network switch or more number of data nodes, or even the complete rack goes down, still your data will be accessible on the other racks. So this is how the fault tolerance is addressed using the replication factor along with the rack awareness up to the level of network switch failures as well as rack failures. So when it comes to the fault tolerance when it comes to file system in traditional storages can be compared with RAID. So RAID is only capable of supporting hard disk failures because the RAID will be configured on the storage server. Okay, if you recollect the legacy architecture, you will have a storage server. This is storage server, and you will have multiple hard disks on this, which will be network mounted onto the compute using network switch, right? So in this case, you can configure RAID on the storage server. If hard disk fails, the data can be created using other hard disks, or if it is striped, RAID have the concept of striping and mirroring. If it is striped, then instead of having the blocks or having the same set of files copied on multiple nodes, it will be striped in such a way that even if one hard disk goes down using the other hard disk, we can actually rebuild the data without causing any issues to the application. If it is mirroring, then you will have multiple copies of the same data, so it no need to rebuild your data set. So RAID have the concept of striping and mirroring. So anyway, if you try to compare the fault tolerance in HDFS with fault tolerance in traditional network mounted file system where RAID is being used, RAID is only capable of addressing hard disk failures, whereas the replication factor, which is similar to RAID mirroring, is capable of not only to deal with hard disk failures but also motherboard failures, the complete node crashes. With the rack awareness, it can also deal with the network switch failures and as well as the rack failures. Rack awareness, so administrators will take care of setting up the rack awareness. The vendors will provide you the script. They have to customize little bit, very little, to support the rack awareness. So as a developer, you don't need to be worried about what needs to be done to set up the rack awareness. So when you have multiple racks, you have to tell how you which nodes are in which rack. So for that, you have to provide some information to the cluster. Okay. So that being said, let's take the other two questions. I think this one is already you are given a scenario, explain how files are stored in HDFS. The file will be divided into blocks of 128 MB except the last one. and the last one will be whatever the leftover size, and then replication factor will make sure that each of these blocks are copied onto multiple nodes in the cluster to support the fault tolerance. How to override parameters such as block size and replication factor while copying files using -D. Like this, you can override parameters. You can have as many -D and parameter name equal to value you want while performing this item, while performing this task. But if you have too many parameters, it can become unmanageable, especially to develop applications, reliable applications which are easily manageable. The better way of doing it is using -conf. So you can create an XML file which is similar to HDFS site.xml or coreset.xml and have multiple parameters. I will demonstrate that so that you guys are more confident about it. So here I am saying the name as override conf. You can give any name. There is no hard and fast rule for the names. And here it will look like this. You have to have a configuration tag. At the higher level, and then you have to have property, and then you have to have name, value. These are the mandatory tags for each of the properties. Okay, so I am trying to have two properties override. Yes, unless they specify as final in HDFS.xml file, you will be able to override. And yes, developers should be able to override the replication factor. I practiced the get merge HDFS command, but it's not allowing in lab. That's fine. Some of the commands will not work because of the restricted permissions. You can actually ignore them as long as you understand those commands. That is fine. Most important commands are put copy from local, get copy to local, and a few other parameters. As a developer, you might not need to have access to everything. And also, please post this question in the discussion board. So I will make sure that it is not because you are doing something wrong. Instead of waiting until the class about these trivial things, please post these questions in LinkedIn groups so that everyone have access to those questions, and they also, if someone else already have the solution, they can also respond to your question. I will come back to that. Let me finish this. I will come back to what is ACL. Okay, so DFS.replication. Here I want to use true, and then DFS dot block size, and I want to use 64 MB instead of 128 MB. So 64 MB can be calculated using 64 into 1024 into 1024. So this is the value 67108.864. 67108.864. So this is for 64 MB. 67108864. Okay. Now I can, let me remove that file. Hadoop FS -rm user root cards data of cards.txt, and then Hadoop FS -put conf What is our file name? Override underscore config.xml, deckofcards.txt. Always make sure you use fully qualified path, so that typically you don't use Hadoop FS-put as part of the applications. You have to have script around it. So always better to use the fully qualified paths to avoid any surprises when you deploy them in the production. And then user root cards, hit enter. I think I have misplaced this parameter, so let me copy this one. It has to be before put. Now it will work. Meanwhile, I will ask the other question. Yes, you will be actually having a configuration file. So before going to ACL, let me answer the Mohan's question. He is asking, is it this running these individual commands with conf XML files tedious? Is there a better way to manage all these commands in production like a central place? Yes, the configuration file will be in the centralized location, but you have to pass it as a parameter. So there will be only one XML file which needs to be overridden for a given application or given set of applications, and you have to use that parameter file to override when you submit those applications in production. You cannot avoid using this one. If you want to use certain parameters on all the applications, then you have to update the original XML files like core site, HDFS site, or XML files. Okay, so next question is, what is ACL by Gopi? ACL is a Linux concept or Unix concept called access control lists. Okay, so as I have mentioned to you earlier, when you look into the permissions, you have owner, group, and others, and those permissions are based on chmod command. If you run chmod command, in this case, again chmod is a Linux based command. Here, using chmod, we can play with these permissions onto owner and group. Okay, so this is owner of the file, this is group of the file. In this case, owner have read and write permissions, and other users in group have read-only permissions, and every other one have read-only permission. Okay, sometimes we might have to deal a situation where only specific user in a group or in others needs to have a elevated permissions than the other people in the group or others. Okay, other than owner, if you think about group and others. So let's say my name is A, who have access on a Linux host, and there is other user B, who is not owner of the file. There can be only one owner for a given file. And if a file is owned by OS user A, and if you want to give permissions to user B, which are not typical to others or other members in group, in that case you have to use ACL. ACL stands for access control lists. It's a Linux command, and I have covered as part of the HDFS commands. Go through that. If you are not clear about what ACL is, you have to practice from the Linux point of view to overcome it. Okay. So group is again, group will be associated with a file, and again, it's a Linux based concept. You can actually divide all the OS users into multiple groups, such as development, production, testing, administrators, etc., or read-only users, etc. So you can actually group users into different groups on each of the hosts in Linux world, and those concepts are inherited in HDFS also. So group is a Linux-based concept where you can create multiple groups for different users. Let's say you have read-only group, and you can if the you can define certain default permissions for the group. You can set the default permissions at the group level, and if you make it as group, all the members in that group will have certain access. Okay, so can we see the available groups? Yes, there is a file called etc slash I think etc slash group, which will give the details about the group names. Okay, and also when you actually if you want to see to which groups a user belongs to, you can give id command and give the username and see to what all groups this user belongs to. So user HDFS belongs to groups HDFS and Hadoop. Okay, and if you want to get all the user details, you can use the command called cat etc password. Cat is just to read the file. Actual details will be under the file, such as etc password or etc pass wd and etc group. Okay, so either you can run view command on etc password pass wd to get the user level details, what all users are there, or for groups you can also do view etc group. Okay, so some people are complaining about audio being breaking. Is it the case only with so are you guys using are you guys dialed in, or are you guys using the one minute? So, let's take a pause for a moment and okay, so don't worry about groups. You can watch those in the video. Is it better now, or is it still breaking? Hello? Okay, so don't worry about groups and users. So even though these files can provide you the details, group and password at the Linux level, you might not have permissions for you. So at the Linux level, it's the role of system administrators who will take care of creating the users, groups, etc. Okay, you just need to understand the concept behind it. So Gopi, if you are interested in, you have to understand what is all these things by going to the Linux material. Okay, Murli is saying still bad. How about other guys? Is it still bad for others too? Okay, I don't know why it suddenly started behaving like this. So anyway, we actually wrapped up, and we can close it now. 2 minutes early. I'm not sure how to fix this issue until I get a different location. But even if I get an office, it could be the problem there also. Internet is not very stable in India. So another question is, like in Informatica, we have workflow manager to manage all scripts mapping. So was checking if Hadoop has such kind of tools. So very good question. It is asked by Mohan. The answer is no. It's not as robust as Informatica Workflow Manager. Even Informatica Workflow Manager might not be the good, very good technology. So people use enterprise workflow tools. In Hadoop, there is a tool called Uzi, but it is not as user friendly as Informatica. And there are other tools such as Azkaban, Airflow, which are more popular. So Airflow is from Airbnb, a company called Airbnb. Azkaban is from LinkedIn. So you can use these tools also to set up workflows for Hadoop related applications. I can take a couple of more questions before we wrap up today. So the question is which certification will be able to take after completing this course. This is more inclined towards CCA, Cloudera Certified Associate. But watching my content on PIG, you can also give HDP CD without Java. Okay, so you can aim for any of these two. I will recommend CCA. If you ask me for the recommendation, I will recommend for CCA, and even the content will be towards CCA. Okay. And also I will send an email the way I have done earlier. Even so far we have only covered HDFS. So you have to practice HDFS commands and practice HDFS commands. So practice HDFS commands and also make sure you set up the development environment on your PC. Practice HDFS commands and also make sure you set up development environment on your PC using STS and Maven. Yeah, I will get you AMI by Monday, Mohan. Yes. So the purpose of Pramod, the purpose of setting up development environment on the PC is to develop MapReduce applications. So I will show one simple MapReduce application. If you want to play with it, you can play with it. So I will highly recommend to set up the development environment on the PC using STS and Maven. It is mainly for MapReduce development. Yeah, but it is not. No, I didn't say that it is not needed. What I said is it will be irrelevant in future, but still you might have to have a little bit of understanding about MapReduce, because there are some Java developers who want to build on top of that. So I will be covering briefly about MapReduce. And also it will actually give you about and also even for Spark, it is recommended to set up the development environment on the laptop. So you have to have it, even though you don't dig into MapReduce quite extensively. Some people might be, but still you have to have the development environment set up on the laptop. So for those who are not interested, it is not mandatory, but it will be better to do so. Okay. Okay then. That being said, I will send you email, and for Mohan, I will get you AMI by Monday. See you on Monday. Bye.